So we're going to start off today by talking about string formatting. Today is mostly going to be about reviewing the accumulator pattern. That's going to be the meat of today, but there was a special request, and I think this is really worth going over again. Tilvio chose to include some material on F strings again, and I think I kind of glossed over this pretty quickly. I may have even kind of showed it before I explained it at some point, so apologies if I did that. But F strings they look a little funky, and they seem like it's easy to, I think, see them as being more complicated than they are. But essentially what it allows us to do is, if we have other information from other parts of our program, like integers or lists or even dictionaries or whatever, and we want to like place that information into a string somehow, and quite often it's done with other strings and like integers or floats, we can use string formatting to help us do that. So hopefully we'll give this a little more attention. And yeah, all right, let me just get my thing going with Zoom here. Is this gonna work? Oh, come on. Okay, Zoom. Sorry. There we go. Okay. So there are two ways to format a string that look slightly different visually in the code, but work exactly the same way. So there's something called F strings or format strings, and then there's the dot format method. So let's look at F strings. So I believe F strings are the Pythonically preferred way of doing format strings. They're my personal preference. Some people prefer the dot format method, but it's just really up to you whichever one you like. So let's say, I have to have some information. I've used this example with where I have like somebody's name is, and their age, which is, let's say, 47. And so let's say I want to print Sally is 47. This is, I mean, obviously I could print this, but what if I don't know these variables, the values of these variables? I don't know the name and I don't know the age before I run this. Maybe I could write a function, right? Def name is age. Takes in a name and an age, and it'll return. Well, I can't really return Sally is 47, because that, that's fine if for a 47-year-old named Sally, but for anybody else, this function isn't going to do the job, right? So when I call this function, I want to be able to, pass in a name and an age. So Bob is 59, and this should return a string that says Bob is 59. So as it sits, obviously we're going to get Sally and her age. So what we can do is use a format string here. There's a number of ways we could do this. I could say name plus is plus age, but I can't, this is a string concatenation, and then that string would be being added to this integer, so that'd be weird, so I'd have to cast this as a str. This will work. This is kind of like string formatting. Maybe this is like what the cave programmers did back when they were programming on stone tablets, and that's all they had. But we're civilized in this day and age, and we have f strings to make this much prettier, right? So this will work. So I can pass a name and an age, and this will be fine. But I want this to be nicer. So thankfully there's a much more pleasant way of doing this. Okay, so obviously I can't just say name is age, because that's just going to be the literal string name as age. So I'm going to use a format string. So we just have our regular string, and then we just stick an F on the front of it, and that makes it a format string. And what this allows us to do is put in curly brackets, like the curly brackets you'd use when you're writing a dictionary. And anything in the curly brackets is going to be evaluated as code, right? So I could sort a list and join it back into a string. Like I can run arbitrary code in here. This particular code wouldn't really help me in this case. Oops, has to be single quotes. But I can run arbitrary code in there, and whatever that code returns is going to be formatted into my string automatically. So notice if I remove this F, in my case, the highlighting is going to change. Depends on your parser and your syntax highlighter, how that's going to work in your editor and all that. But for me, it's going to change. And when I have the F in front of it, I can see this is kind of formatted in that way. And this just looks like a string with curly brackets in it. So yeah, so having the F in front of it is going to allow this information to be formatted in dynamically. So let's look at that. Bob is 59, Joe is 27. So this is a format string. Remember I said there's another way, which is the .format method. And the way this works is we just put in the curly brackets, but we leave them empty. And then in the order the curly brackets occur, we can pass things to be templated in, right? So the first curly brackets will template in the first argument, and the second curly brackets will template in the second argument. And the same thing here. This can be any arbitrary code. So I could print here. I don't know why I would. It'd be weird, but I can run any arbitrary code that returns a value that I want templated in here, right? So let's run this, and we'll see we're going to get the same result. Cool. So you can choose whichever one of these ways you like better. Like I said, they are exactly the same to my knowledge. If there is different behavior with one over the other, or one is capable of something else, the other isn't, I've never encountered that, and I'm not aware of it. Yeah, so everything I know, these are exactly the same. And I believe that F strings are syntactic sugar for the .format method, which means that Python sees an F string and literally just turns it into this after the first parse. We got a question here. Are F strings and dot format only used in this manner, or are there other situations where you would use them? In this manner, like in a function that returns a name and an age. Um, I'm not sure what you mean by in this manner. There uses for when you have a string that you want to have like dynamically generated, right? So like let's say there are words or numbers in the string that you don't know yet, and they're going to be determined by other parts of your code. An F string will like dynamically generate that. So in a function where variables change, this would be one application of them. In a function where variables change would be one application for F strings, but not the only. That's the word dynamic variable. Yeah, I guess that would be a good way of thinking about it. It's like a dynamic string that rather than a string that's determined at the time of writing the code, it's determined at the time of running the code. So it's determined at runtime. You can think about it like that. So this is, this is dynamically determined at runtime, and I'm saying I don't know what this string is at the time that I'm writing it, but I know what structure it should have. I know how to determine the structure. It should say name is age, and I know it should say that because I said it should say that. But and then here's our runtime or whatever. Maybe the name is coming from input somewhere. I mean, let's just model that, right? Like, let's say user input name age, and we can just do this. And then we can say name, age. Okay, so here we really don't know what the name and the age strings are going to be, right? Until it's runtime. And so name is, oops. Really, and age is 809. So Billy is 809. Cool. Yeah, so that's a good way of thinking about it, like a dynamic string. Any other questions on this? Just at me if you have any other questions on this. I think, yeah, this is worth taking questions about, so feel free to bring them if you got them. All right. Da-da-da. Yeah, this is just giving an example of the same thing I did. Okay, cool. So let's move on to the main topic of the day, which is accumulators. Okay, so an accumulator can be thought of as a running total held in a variable. The accumulator pattern is as follows. We initialize the accumulator variable, we repeat some process, and we modify the accumulator variable. I'll usually call this the accumulator target or the target. And that's the thing that we're targeting for alteration, for modification. So we can accumulate on any type. We could have like let's say I wanted to like count like I wanted to count the number of I want to like check numbers in a range and count however many numbers are divisible by 7. I don't know. So we can say div by 7 count equals 0, and we'll say for I in range 20 to 47. If I mod 7 equals 0, so this will tell me if I is divisible by 7, then we'll div by 7 count plus equals 1. So we'll add 1 to our accumulator. This is a ridiculous name. I hate it already. I'm just going to call it ACC for accumulator. So we'll add 1 to our accumulator if I is divisible by 7. And then we'll, I don't know, do something with the accumulator. We'll print it off. How about that? So between 20 and 47, in that range, there are 4 numbers that are divisible by 7. We printed those off just to see what they are. The 21, 28, 35, and 42 are all divisible by 7. Cool. So this would be a silly but valid accumulator. Nice simple one. So this would be accumulating on an integer. Let's say we could accumulate onto, I mean, this would apply to floats as well, this plus equals. This is where the accumulation actually happens, sort of. Right, so there's always like a line where the accumulation or the modification happens. So the accumulator pattern can be a little bit broader than just adding something. There are times when maybe you want to subtract something, maybe you have a list of elements and you want to remove something. All of those kinds of problems end up getting called an accumulator pattern, even if they don't necessarily accumulate. Sometimes you'll hear the term decrementation pattern instead of accumulation pattern. But accumulator pattern sort of gets used as a catch-all for you initialize a state, you run through a loop, and probably check a condition and modify that state accordingly. So that's an integer accumulator. I'm going to say this applies to int and float, even though we're using an int here. It's the same deal with a float. It's trivially different because it's just a float instead of an int. Boolean flags, which are Boolean accumulators. We can come back to that because it can be a little funky. Really, there's not much complexity here. It's just like you start something at false, and depending on a condition, you might change it to true, or you start something at true, and depending on a condition in a loop, you might change it to false, right? So you're just starting it at one of the two states and then changing it from that to the other one in a loop, right? So you check, maybe you check a range of elements and if one of those elements meets some condition, then you swap the Boolean flag from either true to false or false to true. So we can come back to that. We can also have string accumulators. We could have tuple accumulators. We could have list accumulators. We can have dictionary accumulators. And dictionary accumulators, I think, sort of can be split into two categories, either when we have an empty dict or when we know the keys and we're accumulating on the values. Often we do both of these at the same time. We got some comments here. I'm confused when I ran that in Replit. I only got 4. Oh yeah, I mean, I only got 4 here. I was printing out each number. So I added this line. Sorry about that. And that's what printed out the those other numbers. But yeah, you're supposed to only get 4 from this code. You did good. You didn't do nothing wrong. That was me just sort of throwing prints around and making things a little confusing. So if you're only printing the accumulator, we have a comment here. If you're only printing the accumulator, oh, I'm sorry, that's just at that. Good. Seems like everybody's good in there. Okay, cool. So these are just, other types. And really, so we can use any type as an accumulator. I guess we can't use none as an accumulator since it's a unary value. I mean, it only has one state. It's just a state that isn't the state of other states. So what would you accumulate onto it? Although I guess sometimes you start a variable at none and then you change it to some other type. Maybe you could call that a non-accumulator, but at any rate, we can have accumulator patterns for all of these. Oh, I forgot sets. We can do sets. Although in general, I'm kind of the opinion that you could really just do a list accumulator, and if you need it to be a set, you can cast it as a set later, but I don't know. Maybe there's a better case to just do a regular set accumulator. So I'm just showing you this to show that you can do an accumulator with any type. Let's look at lists really quick, because probably lists in integers, and I guess maybe strings would be the ones that get used the most. But you do see dictionary accumulators, occasionally tuple accumulators. So let's look at lists. So generally, we'll start a list as an empty list. And then what do I want to do? I have to have some goal here. If, I don't know, if a number is divisible by 3, I'll accumulate it into the list. Or I'll just accumulate all the numbers in a range squared. How about that? So for I in range 10 to 20. List dot append I squared. Of course, it didn't print anything, so we don't see anything. So we start at 10 and we go up in steps of 1 up to 20, not including 20. So 10 through 19, and these are the squares of all the numbers between 10 through 19. So I accumulated those. This list accumulated those values. So this list is the target for accumulation, and where the append is the action of accumulating. So the action. So the action happens. Okay, so yeah, it occurs to me to mention that we could have we can have a loop that has multiple accumulators. Sum of squares. So let's do an int and a float. So we'll start this at zeros, and we'll say sum squares plus equals I squared. Right, so this is one loop, but we have two accumulators here, right? So cool. So here's our list and then our integer accumulator. So this is maybe a little less common, but you do see it where you'll have, and it's absolutely legitimate to do this. I think I've seen some people avoid this because they're like, oh, well, you know, I should have my or this accumulator separate from that accumulator. But if you can do them both in one loop, I mean, you know, there's nothing wrong with that. So yeah, cool. So let's look through here. Let's look through this material. So we can calculate the sum by using a numeric typed accumulator with enter float. Yep, that's what I showed there. All right. So we got a breakout here. And actually, let me just copy this from the thing. Okay. Oh. 1 second. Let me just get the formatting working on this. There you are. And I'll put 4 minutes on the clock. We got a question here. Does it need to be in this order? It makes more sense to do it in a different order. If it makes more sense to do it in a different order, then I would say, yeah, go for it. Okay, cool. So that's time. Go ahead and put in your answers. Whatever you've got is fine. I see a few answers in here. And I'll do a solution just so we can have that. Okay, so write a function called accumnums, takes in an integer n as an argument. It should perform the following tasks below. So for our range of numbers from 1 through n, integer accumulator should start at 1. The way this is written kind of makes, when I read this, I think that perhaps this suggests that there's some like a rule of thumb that says, well, an integer accumulator should always start at 1, and that's not the case. This is just a note, like in this case, we want to start the integer accumulator at 1. So I'm going to call my accumulator ACC for short, and then start it at 1. So that, just to be clear, this refers to this specific case, not integer accumulators in general. If others found that that this statement was making that suggestion. Okay, so if the number is visible by 3, add 3 to the accumulator. So if num over 3 has a remainder of 0, so num mod 3 is 0, ACC plus equals 1, or excuse me, plus equals 3. If num is divisible by 5, so if num mod 5, excuse me, I'm gonna just do for num, we'll do that. So if num mod 5 is 0, divide the accumulator by 5. Okay, so num equals, or ACC equals ACC over 5. I could do this too, slash equals. Either one of these. And we could say if num, oh, come on, please. Don't move the screen anymore. God. Okay. So if num divisible by 4, so we'll do the same thing. Or multiply the accumulator by 4. So that'll be times equals 4. If num is divisible by 3, 4, and 5, do nothing. So I think what I want to do here is we'll just copy this and I'll say and. So do nothing. I'm going to say that means continue. So we'll just continue on to the next iteration. The reason I want to do this first, oops, should be 3, 4, totally forgot to remember that. Okay. Yeah. This would be 3, 4, and 5. The reason I want to do this first is so that this doesn't get, since I want to do nothing else, I want to run this continue ahead of these, right? If number is divisible by 3 and 4, subtract 12 from it, okay. 3 and 4, we'll say ACC minus equals 12. So that'll be ACC minus 12. 3 and 5. Floor divide the accumulator by 15. Okay. Oh, the steps. So many steps. If number is divisible by 4 and 5, modulo the accumulator by 20. Whew, okay. 4 and 5, that'll be mod by 20. The question about what order to do these in is a good question. It doesn't really say. I mean, the order that you do these in is going to change the outcome. I mean, if you're doing it like I am, where I have consecutive ifs like this, because I'm assuming that a number can be divisible, can have multiples of these conditions can be true, right? Yeah. So I'm allowing them all to execute as they will, and that's because it's not clear in this problem statement that I shouldn't do that, and it kind of alludes to that I should, but there are multiple ways of interpreting this, but this is just hopefully just an exercise to just practice some conditions and accumulation based on those conditions. Okay, cool. So let's see the breakout solution. Okay, it's slightly different than mine, at least. So they did 1 to n plus 1, so they did inclusive there. They checked the compound conditions first. So this is something that I wanted to mention. A lot of times you want to do the conditions that are like multiple conditions with ands in them. You want to do those first because there are certain cases where, especially if you're using like elif, you can end up sort of hiding those conditions underneath, right? So if you have something like if a mod 3 equals 0, do X, elif a mod 3 equals 0 and a mod 4 equals 0, then do Y. The second condition will never run if it's an elif, right? So to me, it's just sort of baked in that if I have compound conditions that have ands in them, the more ands they have, the further they should go in the top. That way, if I'm doing elifs, they don't get hidden in the shadow of the previous conditions. I don't think that matters in this case since we're using consecutive ifs. But okay, so they're continuing under all conditions, under the condition that it meets all of these. Then they do, if it's divisible by 3 and 4, they're checking it in the opposite order, but it's the same thing. Divided by 12, floor divide by 15, 3 and 5. Modulo by 20 for if it's divisible by 4 and 5. And then they check 3, 4, and 5. I'm checking 3, 5, and 4, but yeah, it's all the same code. Oh, and I forgot to return. I wonder who wrote this code. I wonder if it was, yeah. It's rather similar to mine. Anyways, okay. Oh, it looks like we got a couple of questions here. Is it supposed to be inclusive of n? I did not glean from the problem statement that it was. For a range of numbers from 1 through n, to me, if I want something to be inclusive, if I'm writing, perhaps through means inclusive instead of to. I don't know. Maybe there's somebody has an opinion on that, but I would always say inclusive. I would always just explicitly spell that out. And that's, I don't know, that's what I would do. And that's usually what our material does. So I don't know. This isn't like, it's not like we're running it against a test and learn, you know, so there's some, this is a bit open to interpretation. You know, my solution probably looked different than many of your solutions. So doesn't mean they're wrong. Cool. We have another question when it says do nothing. Shouldn't we terminate the function and not continue ramming the remaining conditions? Well, I think in that case I would say no, because you're checking a number in a range rather than the, oh gosh. Yeah, that's confusing. I had num here twice. But in this case, you're checking the number in the range from 1 to n, where n is the inputted value, right? So you're not necessarily checking if n mod 3, mod 4, mod 5 equals 0, all equals 0, then continue, right? You're just checking that one number in the range and skipping that one particular one. Also, if that's how you were interpreting it, then yeah, that's fine. Declare. So why do we need to declare ACC at 1? I mean, it'll work either way. There isn't, it's not necessarily, I think the idea with starting ACC at 1 here is so that you don't get the idea that, I was talking about this with somebody I met with for a mentoring session earlier today about like when to develop a rule of thumb and when specifically to avoid developing a rule of thumb. So if I demonstrate accumulator patterns where with integers where I'm always starting the accumulator at 0, you might think, oh, okay, so whenever I have an accumulator, I always have to start it at 0. And then you'll encounter something where it doesn't make sense to start it at 0. And you'll be like, but wait, you know, I have to start it at 0. And it's true that most of the time I write an integer accumulator pattern, I'm probably going to start it at 0. Sometimes I'll start it at 1. Sometimes I'll start it at something else. But I think the idea with this is like, hey, remember that depending on the problem, you might need to start your accumulator at 0 or at 1. In this case, the decision to start it at 1 is arbitrary. So it's just like, oh, this time we'll start it at 1, rather than it being necessary. This is just a silly function that does random things to this accumulator. So yeah, there. I have an example though of when that would be necessary to not start it at 0, which is factorial. You've seen Tovio and I. Sure, you've seen the factorial function written a few times at this point. So let's do factorial n prod equals 1. So we need to start prod at 1 because the accumulation action is multiplication. So prod equals 1 for I in range 1 to n plus 1 prod times equals I, right? So if we started prod at 0, this would be a problem because factorial 4 should be 24. But it's going to be, anybody guess before my slow code executes? 0. Yep, there you go. Somebody got it there. Well, maybe factorial of something else will be something else. And nope, it's going to be 0 because we've introduced this 0. It's going to be 0 forever. Since times equals is like saying prod equals prod times I, we're just multiplying everything times 0, so it never moves past that. So this would be an example of where if you tried to start your integer accumulator at 0, your function wouldn't work. Let me know if that helps answer your question to the person who asked that. That's a good question. Also somebody else answered it. Thank you. That's also a good answer and basically what I said. I should check for those. Cool. Good. I'm glad that was helpful. Okay, cool. Good. Seems like everybody's doing good. I appreciate how interactive y'all are. I think it makes it fun for me. I think it makes it useful for everybody. So, all right. Accumulators using a string. So, string accumulators. What do you got to say for yourself? String accumulators. So remember, we can concatenate strings. Trying to think of actually a good string accumulator. Huh. Oh. Let's write a function that will uncorrupt some text. Not really, but let's say we have some text with like So we've got these words with symbols that aren't letters that we need to get rid of. So we've got this hello world, and the hello has a 5 in it, and the world has a 2 in it. So let's do something about that. So let's write a function that takes in text, which is a string, and we'll have a string accumulator. I'm going to just call it stracc for string accumulator. I can't call it stir because stir is a built-in function. It's a built-in keyword. I could actually call it string. Why don't I call it string? That's a way better name. That's better than stirac. Okay. String equals just an empty string. And we'll say for C for character in text, if C dot is digit, and actually what I want to do here, if not C dot is digit. So if C is not a digit, it's a little convoluted, but that's what that says. If C is not a digit, then we'll say string equals string plus C. There we go. And of course, since I'm doing this accumulation action here, I can just say string plus equals C. And then return string. And we should have hello world. Cool. So you can see this solves that problem with an accumulator pattern. Perhaps there's another way. Perhaps I could, I don't know, do like dot remove for any occurrence of a digit or something. But yeah, I don't know. This works too. All right, another breakout. Huh, that's, I'm glad I didn't do that because I was thinking maybe I'll do this and it's the problem that y'all are gonna solve. Come on. Oh, come on. There we go. There we go. All right, I'll put 4 minutes on the clock. Have at it. We've got a question using Y as a vowel or no. Takes in a string, returns. Up to you. I don't think this says either one way or the other, so your call. Are we only using plus equals, times equals, or minus equals, etc. for accumulators? Oh, this is a good question. Well, so for this one, you'll use it's a string, so your only option is really the concatenation operator, which is the plus operator. So plus equals is valid for string in this case. I'll touch on this question after the breakout. It's a good question. Cool. All right, go ahead, get your answers in. I'm going to I'll show a solution really quick. Okay, so write a function called build known values, da da da. You all know the drill. So here's my test. Here's my test data. I like to have this before I even have the definition, def. Give me that. And then we'll take in, I'm going to call it text. And I'm going to call my, oops, this is kind of string. Oops. This will be my accumulator. It's with me today. For C in text, if C not in, I should make that lower, A-E-I-O-U. So C dot lower. If C dot lower not in A-E-I-O-U, then we'll string plus equals C. And then when it's all said and done, return, ret run. Okay, now we have garbage text. That's great. Cool. Just thought of a funny alternate way of solving this. We could do string equals text, and then we could say for vowel in A-E-I-O-U, string dot replace v with nothing. String dot replace. That should work as well. Okay, well, there's an alternate solution. Not quite a traditional accumulator pattern. And it's broken. V and, oh yeah. We'll do that. And then we'll get rid of the string there. Okay. So this would be, I would consider this also a kind of accumulation pattern. But a very, there's sort of a different logic happening here, right? The thing we're accumulating on is actually just our input directly, which sometimes you can get away with. In this case, you can get away with it. Since it's a string, we don't need to copy it. We don't need to worry about like messing up the global string. That's not going to be possible in a function. Since strings are immutable, we won't be able to alter the global variable accidentally, which is nice. So then we're just going to iterate through the vowels and run this line of code, and we're accumulating this changed version of text, right? So text is slowly changing, and it's actually changing in a reductive way. We're reducing the size of it. So you could call this a decrementation, but this is a very funny looking accumulator pattern. This is a very traditional accumulator pattern. This is a very kind of different one, and they take two different approaches. but they are both what I would consider an accumulator pattern. Cool. Okay. And here's their solution. And yeah, it's basically my original solution. They're doing continue if the character dot lower is in a list of the vowels. Else, they're doing the accumulation, but sort of just a trivial difference. Oops, collect evens. Okay. Let me see if I can find this. Excuse me. All right, have at it. 4 minutes on the clock. All right, cool. So for this one, def, go ahead and get your answers in, by the way. We'll take in list here, and I'm going to say string equals an empty string, and we'll do for num in list if num mod 2 equals 0, string plus equals num. But we can't just add a num. We can't just add a num to a string, an integer to a string. One is a numeric value, the other is a collection of characters. So this will give us an error if we try to do this. So in this case, we got to cast this num as a string by using the stir function like this. Cool. So if the num is divisible by 2, then we cast it as a string and save it into the string accumulator target. And this looks to be exactly the same code, except yeah, just S. Just S instead of string and I instead of num, but same diff. Sorry, there was a question that I wanted to take about, like, somebody asked, are we only supposed to use plus equals for the actual accumulation? Let me actually go back up. Are we only using plus equals, times equals, and minus equals, etc. for accumulators? It depends on the type, right? You're constrained by the type. We're about to talk about list accumulators. So list accumulators will use append. So list equals empty list. We'll just do list dot append I squared, right? This is the squared list thing again. So in this case, we'll use append to modify the list. There are lots of methods that lists have that will modify their value, and that's what makes them a mutable type. The fact that they have methods that will change their actual value. Strings and integers and tuples and Booleans don't have any such methods. Therefore, those types are what we call immutable. So for mutable types, there are sometimes ways of altering them, and that's really what we're thinking of when we're talking about an accumulator pattern. Like I said at the beginning, like accumulate makes you think that it's growing, which usually it is, often it is. But that's not the only thing that we think of when we think of an accumulator pattern. We use that term sort of loosely to apply to a lot of other things. So you call it the modification pattern, but that sounds sort of too generic. But it's just any time where you're initializing something, you run through some collection or you iterate over some process where often you'll check a condition, sometimes not, and depending on the code in the process, that'll help you determine what the action of the accumulation should be. Sometimes it's reductive, sometimes, maybe I want to accumulate values, but I want to put them in the middle of the list, or I want to put them at the beginning of the list, right? So I would use something else other than append for that. You can use concatenation for lists. There's a way to model similar behavior, although this works a little bit differently under the hood. It appears to work the same, though. We can say list plus equals, then we need to add it to another list so that the concatenation will work. and then we can do I squared. So this will have visibly the same result as appending, although what's happening with concatenating is it's not mutating the same list, it's giving us a different copy of the list. So technically we're sort of using more memory than we need to. But concatenating is, I don't know, I really like this syntax. Like I like the way it reads. So you can get away with this if you want to. Usually that optimization increase doesn't really matter, but traditionally we just used append for altering lists, and that's what you should use really. But concatenating lists does have its place as well. This says sometimes you'll need an accumulator that is an empty list. As the for loop gets evaluated, the accumulator will be appended with new values, etc. Right? So when this says sometimes, very, very often we use lists as accumulator targets because, you know, it's nice to have a list of things and sort of lends itself to the process. Okay. Hopefully that helps answer that question. Can I post my code in here, my solutions? Okay, cool. Yeah, I'll post my solutions. I'm going to post this breakout first, though. There you go, and I'll put 4 minutes on the clock. How about it? Just posted my solutions to the previous questions if you want to look at them after this. All right. So I'm not seeing any solutions yet. I'll finish my solution when I start seeing some submissions. Cool. We got a couple solutions in here. I'm gonna go. Feel free to put your finishing touches on. I'm gonna go through a solution myself. So we'll say forward in text dot split. What do I want to do? I want to if so kind of threw myself a curveball because I'm using multiple. Oh gosh, I'm silly. There's a method for this. If word dot, I think it starts with yeah. So for st for string in list n, if word starts with st, we'll say ost dot append word, and we'll break this loop. Okay, I think that'll do. So beautiful neighbor could be B. Okay, so I started with any, or I'm looking for words that start with any, C, W, and B. And these are all the words that start with those. Okay. Yeah. I feel like I'm missing something. I don't know. Whatever. That's fine. I'll move on. I think I'm just having that feeling, like when you're leaving your house and you're like, what am I forgetting? And you're not actually forgetting anything. Everything's fine. Cool. So they're just doing a single character. So letters is the list. And then they say word sub 0 dot lower and letters. I made this more complicated than it needed to be because I'm like, I don't know, into that or something, I guess. And then, so they just lowercase the letter, which I probably should have done here. I forgot to do that in mine. And then they're just checking for membership in letters. Yeah. Cool. Another breakout. Okay. Oops, let me grab it from here. Oops. Gotta paste it here. Oh shoot. Yeah, sorry. Let me post. There's the new breakout. Excuse me, let me fix the formatting. Apply. It's not going to fix the formatting. Okay. Okay, and let me post my solution to the previous one as well. And there's your 4 minutes on the clock. Okay, we got a couple answers in. All right, I'm going to start on my solution. Okay, so write a function that takes a list of various value types and returns a list of those values processed in the following way. Accumulate elements that are not integers. If the element is a float, change it to a string. If it's a string, accumulate the length of it. Okay, so we're going to say for L in list in, I'll call this LM, LL. For LM element in list in, if type LM equals int, continue, elif type LM equals float list dot append stir LM. Elif type equals stir. Hello. Excuse me, type stir. Elif type LM equals stir. Then len. I think that's it. Okay, so we can ignore the integers and we expect 23.11 as a string, 13 or 3.14 as a string. Table and chair both have 5 characters. Yeah, okay, good. Skip the integer, and then that's good, that's good. This is already a string, but it's a string of a float. So we'll get the length of that. It's 3, which is fine. And then Python has 6 characters, great. Okay, so switching gears a little bit. Oh, that's really weird. So this solution is a little bit different. I think it's actually got an error in it. Yeah, it looks like this is not indented properly. Oh, ain't that just the strangest thing? Okay. Somehow the indentation got all wonky on this one, but there we go. Okay, so this was a little, perhaps this was implied and I didn't glean that, but this is just saying if it's a float, make it a string and append it. If it's a string, get the length and append that length. And then if it's not an int, just append whatever else it was. I think this will work the same because there weren't anything but ints, floats, and strings in that case. But this function is slightly different than the one that I built, but yeah, whichever. Okay, cool. No worries. Those will get you. Cool. So on to dictionary accumulators, and this one is a code along. So sometimes you'll need an accumulator that is an dictionary, a dictionary. Let me save that. That is a dictionary. The accumulator either creates a new key value pair, this is what I was talking about before, or it will add something to the value of an already existing key value pair. So if we start with an empty dictionary, it has to be the former, because there are no keys to have values that we can modify. We have to add key value pairs. That's it. So sometimes, though, you might have a scenario where it's like you have categories that are predefined, and it's like you have cat 1, and you start cat 1 at 0 or something. But that's just being super slow. Oh, because it's rendering the markdown. That's why I'm like, why is it so slow to type here? But it's rendering the markdown live. So, okay, let me take this into my Python document. I forgot to share my solution. Not in that habit yet. Let me get that in. There we go. Okay, so in this case, we have to add key value pairs for this to be useful. But sometimes, occasionally, you'll have a dictionary where the categories are predetermined, perhaps during the time where you're writing the code, or perhaps by some other process where you accumulated key value pairs into that dictionary. But usually you'll start with an empty dictionary. And if you start with an empty dictionary, you have to do the full key value pair accumulation. So this is a good, simple way of doing it, right? So in this case, we're saying if the element is a member of the accumulator keys, then we will modify the value at that key. Else we'll just make it exist. So this creates the key value pair, and this modifies it if it already does exist. Okay, so here's our code along. So write a function that will, for any given string, return a dictionary that gives us the number of vowels, the number of non-vowels. Okay. Dictionary that gives us the number of vowels, number of non-vowels, number of non-alpha characters. Good. Non-alphas are numbers and special characters such as exclamation points, periods, etc. Okay. I think somebody has their mic unmuted. If y'all don't mind just checking real quick. Not exactly sure on that. Okay. Looks like we're good. All right, so this has this all laid out, but I'm just going to do this my own way. So we want to have a function. Let's see, what does this do? So number of, let's just call it string or text analyzer. So def text oh my gosh, I don't know how to spell analyzer. I'm sorry. I am unironically looking this up. Gosh. Oh my gosh. Okay. Word successfully Googled. All right. Text analyzer. We'll take in text. And to remind myself that this function returns a dictionary, I'm going to say text analyzer D for dictionary. Then we'll say D equals an empty dictionary. So I'm just setting up the accumulator, kind of getting the framework, making it easier on myself for working with it. Let's make a test. Let's say, so hello there, how are you? So number of vowels, non-vowels, and non-alpha characters. So non-alphas are going to be easy. So whenever you're working with a dictionary, a lot of times, this is a small bit to work with. So we could probably write the dictionary that we're expecting pretty easily, so we know what to end up with. If you can do that, that's fine. But a lot of times, I'll just write a schema, which I'm going to do here. So a schema is just, it's the root of schematic, the same root as schematic. So just like sort of a plan of the structure of the dictionary, just to remind myself what I want to end up with. So in this case, I want to end up with 3 keys. I'm going to say vowels. And then the value for the vowels key, oops, this has to be a string, make that clear, is going to be an integer. And when I'm doing type annotation, I like to do angle brackets. This is a convention that I follow. You can do whatever you want, but just so you know, that's what I mean when I'm doing that. I'm talking about the type. So will be an integer that reflects the number of vowels. And then we'll say non-vowels and non-alpha. We'll say non-alphas. Both of these are just going to be these string literals. This is going to be, oh yeah, these are just going to be ints. Right, so I could go through here and like count exactly what I'm looking for. I know there's one non-alpha, or actually I think spaces are non-alpha too. So there's 1, 2, 3, 4, 5. So I'll just say 5 in this case because I think that's what I want to do. So I have some expectation of the structure of the dictionary that I'm looking for. So again, I know you've heard me say this, but it's always worth it to take a little time, especially when you're working on a problem that you think you might find challenging. If you're in the middle of a problem that you think is more challenging than you thought it was, set it down, and before you really dig into it, make some sort of clear expectation of where you're heading and work. You can sort of work backwards from there. You know, now that I know what I want to end up with, it's easier for me to go in that direction. And then I have this test that's going to allow me to check as I code. So then we'll do, so we'll say for CH, which is short for character, in text, and we'll just write out these conditions. So I'm just going to write, I'm going to treat this kind of like a checklist, right? And just check these off as I go. So first one I want to check off is get the number of vowels. Okay, so we'll say, oh, shoot. Let me actually use my schema here. Since this case, I know what keys I have, I can just bake these in from the beginning. Okay, so these can be my accumulation targets. Yeah. So if ch in, and well, let's do ch dot lower in AEIOU, then we want to increase this particular integer by 1. So we can say D sub vowels plus equals 1. So you can think about this as very much as a variable name. It looks funny, it has square brackets and quote marks and whatever, but if I had a variable called vowels, or let's say vowel count equals 0, like this wouldn't be difficult. I imagine most of you would look at this and be like, oh yeah, I could figure that out, right? It's the same. Oh, and they're even the same length. That's kind of nice. But it's exactly the same, right? So in the variable example, I've got this variable that is a pointer to this particular integer, and has that value of that integer, and I can modify it with plus equals, and exactly the same can be said about the dictionary. It's just that these three variables, if you will, are collected into the one dictionary, and I can kind of treat it as a single volume that works together. So, okay. So if ch.lower in AEIOU, it's a vowel, we can add a count to vowel. Elif, if it's not a vowel, if it's not a vowel, we can, I think we can just do else, because this is if it is a vowel, yeah. So this will say non-vowels plus equals 1. And then non-alphas are going to be, I think we can just do if D dot is alpha. Oh, what am I doing? If ch dot is alpha. And we can say not. Then cool. Let's see what that does for us. Awesome. That looks like it works. Remember, we set the expectation of 5 for non-alphas. Looks like there's 9 vowels and there's 15 non-vowels. I imagine that the non-alphas will also count as non-vowels. So a space would not be a vowel. So in this particular case, the way I wrote this, it'll not be a vowel as well. Cool. So let's just look through and see the way they did this. Checking for membership in a list of vowels. We're starting with that template dictionary where we know our categories ahead of time: vowel, consonants, non-alpha, etc. They're checking this condition. Looks like that's the second condition they're checking. And then it looks like else is going to be the non-vowels. A little bit of a different take on the instructions here, but I think that's okay. Cool. All right, we've got another code along in here. You can kind of look through, and we won't go through it because we don't have time, but I'll assign this as part of homework. Just kind of step your way through it and think about each step. Kind of go through it like I did this. I would suggest starting with somewhat of a template before you set off on your actual problem solving. So you want to start with something like this where you have your function name, you have the start of your accumulator and your return so you can monitor as you go, and then your test, and do a little work about writing down what you expect that test to return, at least in terms of its structure. You can take a note on its types. You don't have to use the angle brackets, just whatever makes sense to you. And then from there, you can take it step by step in the problem solving and just go line by line and solve the problem that way. Cool. So that's it. I'll call class early. If you want to get out of here, then enjoy the rest of your day. If you want to stick around for questions, then feel free to do that too. And give me 1 second. Let me stop the recording.